Diffraction grating. What is the meaning of diffraction grating? Basically, diffraction grating is a combination of n number of slits, n number of parallel slits. They are equal in width and spacing between them that is also equal. So n number of equivalent slits which are placed parallel to each other and separated by equal distance, then that combination is called as grating. So if you are having a grating like this type of glass plate is there, and here these are the slits like this, and in between them this is space, that is opaque space. So wherever I'm drawing the line, this is a slit, so light can pass through these slits, and spacing between them is opaque. So this type of arrangement of parallel slits, equivalent slits, that is called as grating. So here light can pass through the slit. If you look at slit, light can pass through it, and in between them there is an opaque space through which light cannot pass. So this type of arrangement, this is called a diffraction grating. So here, if you are having n number of slits, then we can show these slits like this. This is first slit, second slit, third slit, fourth. In this way, there are n number of equivalent slits. It is like this, and it will so on. Okay, so total n number of slits will be there. Capital N is the total number of slits. So first thing is, what is n? N is total number of slits. Total number of slits. First, okay, total number of slits. Now, what is the slit width? So if you are having a slit like this, suppose I'm drawing a, and this is next one. This is next slit. So width of each slit, we are assuming this is small e. Okay? So width of each slit is E. E is the slit width. And this opaque space, width of this is opaque space, this opaque space width, that is D. So in this way, so E is the slit width and D is the width of the opaque space. So what will be the center to center separations? Center of one slit will start from here. For the next slit, next successive slit, this will be like this. So this separation, as in case of double slit experiment, this will be E plus D. ठीक है ना? This will be E plus D. So separation between two slits is E plus D. ठीक है? Separation between two nearby slits, that is E plus D. And here in case of grating, we call this E plus D as grating element. What we'll call it? We call it as grating element. Grating element. So if someone asks you what is grating element, grating element is the separation between two successive slits. So what is grating element? Grating element is the separation between two successive slits. That is grating element. Now, if width of the, if I'm saying suppose W is the width of the grating, width of the grating, of the diffraction grating, then width W will be total number of slits are n, and separation between two successive slits is E plus D. So this E plus D will be like this. So width of the slit will be equal to N into E plus D. So what is N? N is total number of slits, and this W is the width of the slit, and E plus D is grating element, which is the separation between two successive slits. So first important thing is this. Now, how to calculate this grating element? ठीक है, so in most of the numericals related to grating, first you have to calculate grating element. ठीक है, grating element बेटा. So So how you are going to calculate grating element E plus D? Try to understand.
सर
They may, yes, beta, please.
प्रीवियस स्लाइड दिखा दीजिए एक बार।
Okay, beta.
हो गया सर।
Now, there may be different type of questions where suppose I'm giving you width of the grating is suppose 10 centimeter, 10 centimeter, and total number of slits. Suppose they are 50,000, 50,000. So what is this total number of slit? Total slits. So in this case, it will be very simple. This will be W upon N, and you will calculate it like 10 centimeter divided by 50,000 centimeter. It will be like this. ठीक है? Many times this is first type of problem may be there. They may give you total number of slits available on the grating and width of the slit. Then you can use this formula. Second, they may give you, suppose they are saying 20,000 lines or slits. Slits are also known as lines. 20,000 lines or 10,000 I should write. Just 1 second. I'm writing 10,000, suppose 10,000 lines per centimeter. They may give you this type of data. There are 10,000, there is a grating which is having 10,000 lines per centimeter. Then what you are going to do here, E plus D grating element will be in 1 centimeter. Okay, this is 1 centimeter divided by this 10,000 lines. This is. So this will be the grating element. Sometimes they may give you 20,000 lines, suppose lines per inch. Per inch. Now 1 inch will be how much centimeter? 1 inch is equal to 2.54 कितना? 2.54 centimeter. ठीक है ना? 1 inch will be 2.54 centimeter. ठीक है? So this will be. So these are not total number of lines. They are providing you 20,000 lines per inch. So here in third case, E plus D, it will be equal to, this will be 1 inch. 1 inch is equal to 2.54 centimeter. In 2.54 centimeter, there are 20,000 lines. So this will be the grating element. So in these three ways, they are going to provide you the data, and you can easily find out here the grating element. So first objective in most of the question is to find out the grating element. So what is grating element? Grating element is the separation between two successive slits. Between two successive slits. Is it clear? Please note it down. Now.
सर
Yes, beta, please.
सर ई प्लस डी को ही ग्रेडिंग एलिमेंट कहते हैं।
Yes, E plus D is known as grating element. This is
यस सर।
grating element, beta.
सर ये जो डाटा आप प्रोवाइड कर रहे हैं ये सर फिक्स डाटा है।
No, this is not a fixed data. I've just taken an example here. These are the examples. They may change the
ओके।
data here. In place of 50,000, they may give you 40,000. They may give you 20,000. It may
यस
be
सर।
5,000, it may be 20,000. So data may be different. Just I have
यस
given
सर।
some numbers and then I explained you how to calculate it. So this
यस
is grating element, E plus D,
सर।
grating element. Now, next, before going to the diffraction grating, if you are having n number of, I have solved this problem. You are having n number of point slits. Okay? We are aware that suppose you are having n number of point slits. So light is I have done this problem in interference. So if you are having n number of point slits and this planar wavefront is incident, okay, and light is emerging from each, these are point slits. So here, from here, here, from every slits, what you are having from n number of slits, light is reaching at this point. And here you have placed a screen. So on this screen, at a point here, okay, what will be the intensity? If n number of slits, in between which successive phase difference is delta. So what you are having n number of, what I'm saying you, n number of coherent waves, number of coherent waves, and and phase difference between two successive waves is कितना, is, बोलो बेटा कितना था, and successive phase difference is delta. Successive, I should write like this. Suppose delta is the successive phase difference. Successive phase difference. Phase difference between, ठीक है ना, successive phase difference is delta, means in between first and second this is delta, between second and third it is delta, between third and fourth this is delta. Then what will be the intensity at this point? IP, and amplitude of each wave that is emerging from here is A. ठीक है? So if interference is taking place at point P, so here what is this? This is N slit interference. N slit interference. Interference. If n number of waves they are superposing here, they are interfering here, then as a result of this interference, what will be the intensity here? IP. That will be, बोलो बेटा, sin square n delta by 2 divided by sin square delta by 2. This will this will be the intensity at an arbitrary point. This will be A square sin square n delta by 2 divided by sin square delta by 2. What is delta here? Delta is 2 pi by lambda. 2 pi by lambda. Here, because they were point slits, so this was equal to d sine theta. D sine theta. ठीक है? If you bring 2 here, then this will be delta by 2 and this will be pi by lambda here and this will be d sine theta. And we assume that this is beta. I'm assuming this is beta. In case of diffraction, width of the slits will be significant. So this will become, in place of D, it will be E plus D in case of n slit diffraction. Okay? In case of interference, because we are choosing point slits, so this was D, E was 0 here. Here's width, slit width was considered at to be nearly 0. Okay? So this will be here. So you are going to write it like this: sine is A square sin square n beta divided by sin square beta. This will be. This is the intensity at the point P. A square sin square n beta divided by sin square beta. ठीक है ना? This is the intensity at the point P. Is it clear? Do you remember this formula? Now I will use this formula here for n slit diffraction. Here, diffraction grating or n slit diffraction. Diffraction grating. So you are having n number of slits. Width is E. This will be planar wavefront is incident. Planar wavefront is incident like this. When light will emerge from these slits, because width of the slit is of the order of lambda, so at individual slit diffraction will take place. So try to understand, at every slit diffraction is going to take place. At every slit. When light is emerging, diffraction is going to take place here. Now, after diffraction, if I assume the part of the wave that is propagating at an angle theta, ठीक है? So from every slit, ठीक है ना? Try to understand, from every slit, light is emerging and this is the diffracted light. Intensity of the light is going to change from one angle to another angle. In different direction, intensity of the light will be different. And if you observe the single slit diffraction pattern, then you are aware that this type of pattern we are going to get. ठीक है? So in every direction, different intensity light is propagating. So what I do, I choose a particular angle theta. So I choose the part of light from all the slits which are moving parallel to each other and they are traveling at an angle theta. What will be the successive part difference between two? So you have to draw a perpendicular. So this will be the part difference. This part difference will be E plus D sine theta. ठीक है? This separation is E plus D. E plus D is the separation between two successive slits. This is theta, so automatically this will be theta, and this part difference, this will be delta. This is going to be delta. Delta will be the successive part difference between two successive waves. If you choose this one and this one, this will be the part difference. So part difference between two successive waves is same. How much is this? This will be delta. Part difference will be how much? Part difference will be E plus D sine theta. I have done many times this thing, so I'm writing directly. This is the part difference. From this part difference, I have calculated phase difference. And if I take this 2 here, then this delta by 2 will be there. And we call this delta by 2 as beta. And this will be equal to pi by lambda. And this will be E plus D. So remember this, whenever this E plus D is coming, wherever E plus D is coming, you are talking about interference. Interference is going to take place. And when only E is coming, alpha is there. Alpha is pi by lambda E sine theta. When alpha is coming into when E is coming into the picture, then you are talking about the diffraction at individual slit. And when E plus D is coming into the picture, means you are talking about the interference. So remember this. Now what you do? Basically, these n number of waves, they are traveling parallel to each other. These part of the waves, they are going to interfere at infinity. But I want to observe this pattern on the screen, not at infinity. So what you do here, you place a lens here. What you do here, you place a convex lens like this. Like this here. ठीक है? And here we place the screen. So here is the screen. This will be. Now, what is going to happen? All of these waves, after passing through this, they're passing through this convex lens, and separation, this screen is at a distance of f from this lens. F is the focal length of this convex lens. So where you have placed this screen? In the focal plane. So you have placed the screen in the focal plane of this convex lens. So when this parallel beam of light is incident on this convex lens, then after passing through this, all these, they will focus at a point in the focal plane. So they will focus here in the focal plane at some point like this, like this. And they are going to interfere, they will superpose here, and they will find out the resultant intensity as a result of interference. So here, n number of waves, they are interfering. So what will be the intensity at this point P? Now you are going to tell me what will be the intensity at this point P. ठीक है, what will be the intensity here? So intensity at this point P will be n number of waves in between which phase difference is this delta. What will be the intensity? That will be amplitude square. A is the amplitude of individual wave, and this will be sine square beta, sine square n beta divided by sine square beta. This will be the intensity. ठीक है ना? This will be the intensity here. Now what will be A amplitude of each of these waves? What will be amplitude here? Amplitude A of individual waves will be anyone. That will be capital A sine square sine alpha upon alpha. This will be. And what is alpha here? Alpha, it is coming into the picture due to the diffraction at individual slits. This will be E sine theta. This will be E sine theta. ठीक है? So place here value of this A, which is this amplitude, it is varying with angle theta due to the diffraction that is taking place at individual slits. So place this expression of A here. So intensity at this point P, arbitrary point P, I, it will be A square sine square alpha upon alpha square. This is amplitude square into this factor sine square n beta divided by sine square beta. Sine square beta. So this is the expression of intensity on the screen. This will be the expression of intensity on the screen. So you have to remember this. What is this? This part sine square alpha upon alpha square. This is due to diffraction. Diffraction taking place at individual slits. At individual slits. ठीक है, this is due to interference that is taking place between n number of coherent waves. N number of coherent waves. So this formula you have to remember. ठीक है, this formula you are going to remember. Now if you plot this intensity here on the screen, ठीक है, if you plot this intensity here on this screen, what type of pattern you are going to get? First is what type of pattern we are going to get on the screen. So from here questions start, ठीक है ना? So first question will be related to the diffraction pattern of a grating. So what type of pattern it is going to be find out. So try to understand. Now,
So
if you
one
are
minute,
having,
the previous
oh,
slide.
yes, beta, please.
Thank you, sir.
Okay, beta. Now, if suppose individual slits slit diffraction is taking place, then this type of pattern will be there. Okay? You're going to have this type of pattern if diffraction due to individual slits is taking place. So this is the plot of sine square alpha upon alpha square as a function of angle or alpha. This type of pattern you are going to get. If if n number of point slits are there and only interference pattern is formed, then you will have this type of pattern. If n number of slits are there, point slits are there, and only interference is taking place. Okay? Here, if only one slit is there and diffraction is taking place, you will get this type of pattern. If you are having n number of point slits, only interference is taking place, no diffraction is there, then you are going to have this type of pattern. You will have principal maximas. In between principal maximas, you will have secondary maximas like this. You will have this type of pattern. This type of pattern you are going to have on both sides. It will be this type of pattern. This is the plot of sine square n beta, ठीक है ना, divided by sine square beta. This is the plot of this. ठीक है? Individual diffraction, individual interference. But if both are happening, first diffraction is taking place and then interference is taking place. So first diffraction and then interference. So first diffraction at individual slits. Diffraction and then n slit interference followed by n slit interference. So both are taking place. What is the consequence of this? It means due to diffraction, light of different intensities is traveling in different directions. Okay? So what is the consequence of this? If you look, consequence of this diffraction is intensity of light will vary, will be different in different direction, will be different in different directions, in different direction, in different directions. In different directions, intensity of light will be different. Now, what will happen, friends? Okay. Now, due to this, basically you are getting this type of pattern because, but now try to understand at different angles, intensity of light is different. So these peaks, the heights of these principal maximas will be modified corresponding to intensity of light available in different directions. So what is going to happen in interference? So height of principal maximas, height of principal maximas, principal maximas will be modified, will be modified in different directions. This will be. So this will be there. So what is going to happen here? Now, if you plot this, suppose this is single slit, this is single slit diffraction pattern. ठीक है? So this is called as diffraction envelope. So try to understand here. These are principal maxima. These are secondary maximas. What is this white line? This is diffraction envelope. So height of these, that is going to modify. This height is going to be modified corresponding to the intensity of light available in different direction. So what type of pattern you are going to have? Your pattern will now become like this. So this pattern will be, now this height will be modified. So this height of these principal maximas will be modified here. So this type of pattern you are going to get. Okay, here there will be a missing order. Here a principal maxima is absent because of the missing order, as we have discussed in double slit diffraction experiment. So here at the position of diffraction minima, if principal maxima is falling here, then that will be absent because in this particular direction no light is traveling. When light, there is no light traveling in a particular direction, no question of interference, no principal maxima in that direction will be formed. So this type of pattern you are going to get as a result of n-slit diffraction. So here two type of maximas are there. These are called as principal maximas. They are principal maximas, ठीक है? And these they are called as secondary maximas. Secondary maximas, because their height is is very less as compared to principal maximas, and in between principal maximas and secondary maxima there are minimas. Minimas, ठीक है? Here minimas means where intensity I is 0. So three type of aspects are there. Principal maximas are present, secondary maximas are present, and these minimas are present. Is this clear up to this point, beta?
Yes, sir.
Okay, beta. Next.
Yes, sir.
Next question is, first question is very simple. Just by observing this formula, if you look at this formula, I equal to E square sin square alpha upon alpha square sin square and beta upon sin square beta. Who is deciding the position of principal maximas? Who are deciding these principal maximas? They are actually interference maximas. They are interference principal maxima. So who is responsible for these principal maximas? This term. This term is responsible for principal maximas. So interference, this term is responsible. I should write interference here. So whatever principal maximas are there, that will be governed by this. ठीक है? High principal maxima will be governed by this. What is this? Interference, position of interference maximas, it will be governed by this. And height of the principal maximas is going to be governed by this. So position of interference maximus will be governed by this. govern. And what this term is going to do, this is diffraction term and this is going to decide, ठीक है ना, it will decide the height of the principal maximum. Height of the principal maximum. Principal maximas will be governed. So whatever mathematics we have studied, particularly limit, ठीक है, whatever limits we have studied in our class 11 or 12, ठीक है, from that understanding I can tell you one thing. If look here, if alpha this beta, not alpha this beta, beta is tending to plus minus you can say n pi, ठीक है, beta is tending to n pi, then what this term will be, if you look at this sine n beta upon sine beta. So if you place here this n is integer, so if you write n into pi, this will be 0 and this will be 0. So this will be 0 by 0. ठीक है? This will be 0 by 0. So what will be the limit? How can you find out the limit of this? Limit, in the limit, this beta tending to plus minus n pi sine n beta upon sine beta. It will be how much? First you are going to differentiate this numerator and denominator. So this will give you n cos n beta, or I should write sorry, limit beta tending to plus minus n pi. So here, or I should write, it's better to write like this. First differentiate this. This will give you cos n beta divided by cos beta, where beta is equal to plus minus n pi. It will be like this. If you place here plus minus, if you write here plus minus n pi, so this will either give you plus minus 1, either plus 1 or minus 1. So what can you get here? You will get plus minus n. ठीक है, this will be. Substitute here n pi plus minus n pi. So this n is separate number. So from this you will get plus minus 1, or here you can get plus minus 1 just. So here what can you get? This will be plus minus n. So when beta is equal to n pi, ठीक है, what I'm telling you, if beta is n pi and substitute this plus minus n, this value of this here, ठीक है. So what I'm saying, when beta is n pi, then intensity will become a square sine square alpha upon alpha square, and here you are going to write plus minus n and square of that, so this will be n square. This is the maximum intensity you are going to find out. What you are going to find out? You are going to find out that this is the maximum intensity. This is the maximum intensity beta, and we call it as principal maxima. This is the intensity of the principal maxima. So what is this? From our pattern, if we check this intensity, these are the intensities of the principal maximas. ठीक है? So what is the expression for the intensity of principal maxima? This will be the expression. This will be the expression. Now, these are the positions of principal maximas. Here you can write principal maximas. So this is the intensity. And what will be the position of principal maximus? For this beta, position will be given by this beta is equal to plus minus n pi. And what is beta? Beta is, if you look at pi by lambda, this is E plus D sine theta. That will be plus minus n pi. So angles which are corresponding to this equation, at those angles you are going to get principal maximas. This pi is going to cancel out, and your equation for principal maxima will be this. Because this will depend upon n, I am writing it as sine theta n. So this will give you the position of nth principal maximum. And this is called as the grating equation. You call this equation as grating equation. This equation provides you the position of principal maximas. And this equation is called as grating equation. Most of the time, in case of grating, you are going to use this equation. You can write here, this equation provides us the position of, this equation provides us the position of nth principal maximum. Provide us the position of nth principal maximum. Nth principal maximum.
सर
Yes, बेटा.
ये E प्लस थीटा लिखा है आपने.
E plus D है बेटा ये. This is wrong. This is E plus D. E plus D. This is E plus D. Now, next is where will be the minimas?
Sir, nth position maxima.
This is the, you can write this equation provides us
Yes, sir.
the angles or the angular position. You can write the angular position of nth principal maximum.
Okay, sir.
Angular position of nth principal maximum. Angles you can find out theta n corresponding to nth principal maximum. Now, next is minimas.
सर n की वैल्यू 0 से स्टार्ट होगा.
हाँ, n का वैल्यू बेटा it will start from 0.
Okay,
This
sir.
will be 0, 1, plus minus I have written here,
Yes,
2,
sir.
3, 4, like this.
Okay, sir.
So if you look at this diagram, here this is n equal to 0. This is n equal to 0. This is n equal to plus 1. This is n equal to minus 1. This is n equal to minus 2. This is n equal to 2. And n equal to 3 is absent here. N is minus 3 is absent here. It is like this. So these n are there. Now, next, minimas. Second, I can find out very easily minimas. Okay, where will be the minimas here? For minimas, one, I know that intensity will be 0 at the position of minimas. So about minima, I know one thing that minimas, for minimas, intensity will be 0. Intensity will be 0 for minimas. I'm not talking about diffraction minima. I'm talking about interference minimas. Okay, how can you find out diffraction minimas? If you make sine alpha upon alpha equal to 0, that will give you diffraction minima. But I'm talking about these interference minimas. Okay, I'm talking about these minimas. This minima, they are interference minimas. So I have to place the part that is responsible for interference. So for interference, this part, sine of n beta upon sine beta. It should be 0. It should be 0. But here, it should be 0. But here, we have to take care of this, that sine beta should not be 0, but sine beta should not be 0. Why? If sine beta, try to understand, should not be equal to 0 here. So minima will be formed at those position where this is equal to 0, but sine beta should not be 0. Reason is, if sine beta is becoming 0, then it will be 0 by 0, and you will be at the position of principal maxima. And at the position of principal maxima, the intensity is not 0, that is maximum. So we have to avoid this situation. This condition should be satisfied, but this sine beta, it should not be equal to 0. Otherwise, you will be at the position of principal maximas, and at those position, intensity is not 0. So for this, I will write this sign of n beta. I am making it 0. ठीक है ना? I will make it 0. So from here you can write n beta. N beta. ठीक है? So remember, this n beta should be equal to plus minus m pi. So if you write m pi here, automatically it is going to be 0. ठीक है? It will be 0. So what is beta? Beta is, that is pi by lambda e plus d sine theta. Because m is there, I am writing it as m. So plus minus m pi. So pi will cancel out, and my equation will be n e plus d sine theta m plus minus m lambda. This will be the condition. This will be the condition for minimas. ठीक है? This is the condition of minimas. You can write here, this is the condition of minimas. This will be the condition of minimas. ठीक है? But remember this, that m should not be equal to, ठीक है ना? On the next line, I will write on the next slide. Please note it down first. Can I go to the next?
Yes, sir. Yes, sir.
This will be n e plus d sine theta m is equal to plus minus m lambda. Can you tell me what will be the values of m? Bolo. I'm writing here. I'm writing 0, 1, 2, and then it will be n minus 1 beta. ठीक है? Then there will be n. There will be n plus 1. ठीक है? It will be like this. You may continue like this again. This will be here 2n minus 1. Then there will be 2n. Then 2n plus 1. Continue like this. Then there will be 3n minus 1. There will be 3n. There will be 3n plus 1. And so on. And it will go on, go on. And here it will be nn. Here it will be nn minus 1. It will be nn plus 1. And so on. Can you tell me which values of M are not possible? Try to understand. What is the
So,
condition of principal maximas? Look here. Those
so
values of
directly,
M will not be possible. ठीक है ना? Those values of M will not be possible, which will convert this equation into the equation of principal maximus. So condition of principal maximus. What is the condition of principal maximus? That is E plus D sine theta n is equal to plus minus n lambda. So this equation should not convert into this, otherwise that will be the position of principal maximus. So if you look at 0, this 0 is not possible. Try to understand. If you write 0 here, then there is no meaning of this n. N is a number. So this equation will be E plus D sine theta equal to 0. That is here value of n will be 0, 1, 2, 3. So this first equation is E plus D sine theta equal to 0. So if you place 0 here, you will get this equation. So this 0 is not possible. If you look at this n, substitute this n here, then n will cancel out from the both sides. And this equation will be E plus D sine theta equal to plus minus lambda, and you will be here. So this is not possible. If you place 2n, then this is not possible, because if you place 2n, this will be n E plus D sine theta m equal to plus minus 2 lambda. And n will cancel out, and E plus D sine theta equal to plus minus 2 lambda. So this n is not possible. This is 3n is not possible. 4n is not possible. So these are not, because what is this 0 representing? This is the position of 0th principal maxima. Principal maxima. What is this? This is first principal maxima. First principal maxima. This is second principal maxima. This is the position of third principal maxima. This is the position of nth principal maxima. Nth principal maxima this is. So in this way, only these values are possible, 1, 2 up to n minus 1. So this is 0th, this is first, this is second. Can you tell me in between two principal maximas, how many minimas will be there? How many minimas will be there in between two principal maximas?
three.
Hello?
Three.
No,
Yeah,
not 3.
three.
This is n minus 1. From 1 to n minus 1. This will be n minus 1. So what you are observing here, that in between two successive principal maximas, two successive principal maximas, there will be n minus 1 minimas. This will be. So here, from here, I can conclude that in between two principal maximas, there will be n minus 1 number of minimas. So if you can count minimas, then you can always find out the total number of slits a grating is having. So try to understand, if you are here, for example, how many minimas are there between two principal maximas? This and this. So this is 1, this is 2, this is 3, This is 4. So how many minimas are there? 1, 2, 3, and 4. So n minus 1 is equal to 4. So total number of slits will be 5. So how many slits will be there? There will be 5 slits. So if they are providing you this type of pattern, you can always find out the number of slits. Okay? So in exam, they can create this type of question. This type of pattern will be there, and they will ask you how many total number of slits are there this grating is having. How many total number of slits this grating is having. So just count these minimas in between two principal maximas. Okay? Just calculate this, and that will be n minus 1. That will be 5 here. Okay? Here four minimas are there, so n will be equal to 5. N will be 5. Okay? Now, if they ask you how many secondary maxima are there in between two principal maximas, so minimas are 4, and in between 4 minima automatically three secondary maximas will be there. So this will be 1, 2, and 3. So they will be one less. Number of secondary maximas will be one less as compared to number of minimas. So here 4 minimas are there, and in between 4 minimas, there will be 3 secondary maximas. Okay? There will be 3 secondary maxima. So here you can write this point. Okay? In between two successive principal maximas, there will be n minus 2. There will be n minus 2 secondary maximas. Secondary maximas. Okay? This will be. So position of minimas you can find out from here. However, they will not ask you to calculate the position of minimas. Remember this. Okay? They are not going to ask you to calculate position. But remember this. This is the equation that is providing us the position of principal maxim. Position of minimas. Position of minimas. Is it clear up to this point?
Yes, sir.
Yes, sir.
Okay, beta. Now next. Now about secondary maximas. Okay, about secondary maximas. Next is secondary maximas. So secondary maxima, they are localized maxima. They are not going to have the highest intensity, no, but they are localized maxima. From their neighborhood, they are having maximum intensity. In their neighborhood, they are going to have maximum intensity. So what they are, they are localized maximas. They are localized maximas. What they are localized maximas. Now, for localized maxima, what will be the condition? Di by, you are talking about interference maxima. So this will be di by d beta, and you will make it 0. Okay? And now what is I? I is a square. A square will be out. This is alpha, so this will be sine square alpha upon alpha square. This will be out. And second will be sine square n beta upon sine square beta. So if you differentiate sine square n beta upon sine square beta, that will be 2 times sine of n beta divided by sine of beta, and then differentiate this. If I differentiating this will become sine square beta. Differentiation of this will be n cos n beta, and this will be sine beta. ठीक है, differentiate this, and this will be as it is, sine beta will be as it is, minus, place this sine n beta as it is, sine n beta as it is, and this sine beta will be cos beta, and make it 0. ठीक है, now there are 3 factors, and you can make each of these factors 0. If you make this factor 0, remember this, if you make it 0, what you will get? If you are making it 0, what you are going to get? You will get diffraction minima. I'm not interested into this. Diffraction minima. This will give me the condition of diffraction minima. And we know this from single slit diffraction experiment. If you place it 0, what you will get? You will get interference minima. We have just done this. We have already analyzed this. Interference minimas. So this analysis we have already done. Minimas. So our interest, the secondary maxima, if they are there, that will be according to this equation. So make this equal to 0. So sine square beta into 0, that will be 0. So this numerator, I'm going to place it 0. So what it will be? This will be n cos n beta sine beta. And on this side, I'm going to have sine n beta, and this will be cos beta. So if I bring this cos beta on this side, this will be sine beta upon cos beta into n. So what I do, I write this is n here, sine beta upon this cos beta, this will be tan beta. And you take this cos n beta on this side, so this will be sine n beta upon cos n beta, that will be tan n beta. So this is the condition. Remember this is the condition for secondary maximus. This is the condition of secondary maximus. So here, this is the condition of secondary maximus. Please note it down quickly. This is the condition of secondary maximus. Now, tan n beta equal to n tan beta. What I want to find out the intensity of the secondary maximus. Why I'm doing this? I want to find out the intensity of secondary maximus. Only after that I will try to find out their position if required. So here, what is the formula of intensity? That is A square sine square upon alpha square. And this is sine square n beta upon sine square beta. I want this one. This is my objective to find out. ठीक है ना? This is my objective that I want to find out. Now, okay. Now, this is tan n beta, so use the basic trigonometric ratios. So if I say this angle is n beta, okay, then I can write this tan n beta is this. So this is perpendicular, so this will be n tan beta, and base is 1. Base is 1. So if base is 1 and this is perpendicular is n tan beta, then from okay, Pythagoras theorem, this will be 1 plus n square tan square beta. Why I'm doing this? Actually, I want to find out this sine n beta. So what will be sine n beta here? ठीक, I find out here sine n beta. Sine n beta. That will be perpendicular here. This is n tan beta divided by this hypotenuse. This is 1 plus n square tan square beta. It will be like this. Now, you want sine n beta upon sine beta and square of that. So I divide this equation by sine beta. So this will be sine n beta upon sine beta. So this will be n tan beta. ठीक है, and here I write this is sine beta upon cos sine beta upon cos beta divided by here. This is square root of 1 plus n square tan square beta, and here sine beta will be there. So this sine beta is going to cancel out and square both the sides. So this will be sine square n beta divided by sine square beta. So it will be n square. Make the square, this square root will be gone. Cos beta will be in denominator. So this will be cos beta into 1. So this will be cos square beta plus n square tan square beta into cos square beta. Cos square beta will cancel out and this will be n square sin square beta. So this cos square beta will be 1 minus sin square beta. So this term will become simply n square upon, this is 1 here, minus sin square beta. So 1 plus n square minus 1. This will be sin square beta. This will be sin square beta. Substitute this value here. ठीक है ना? Substitute this value here. I'm writing this term again here. This I is actually a square. So I want to find out intensity of secondary maxima. So this will be a square sin square beta sin square alpha upon alpha square. ठीक है? And this is n square and this will be 1 plus n square minus 1 and this will be sin square beta. Now if you look at this, what is this? What is this? A square sin square alpha upon alpha square into n square. What is this? ये किसका intensity है? This is the intensity of, किसका intensity है बेटा?
Principal maxima.
This is the intensity of principal maxima. So IS, intensity of secondary maxima, is intensity of the principal maxima divided by 1 plus n square minus 1 sin square beta. So this is going to be the, this will be the intensity of secondary maxima. And ये जो n है ना, this n is very very large. It will be 10,000, 20,000, 30, 40, 50. And here this is square. 10,000 is square, 10 to the power 6. ठीक है? So you can understand that intensity of the secondary maxima will be negligible as compared to principal maxima in diffraction grating. ठीक है ना? For grating here. For grating, This n is very, very large, huge, 10 to the power 3 or 10 to the power 4 like this. So from here, IS is much, much greater than, sorry, much, much less than IS, that is much, much less than IP, principal maximus. So that's why there is no need. When you are observing the pattern, you are not going to observe the secondary maximus. So that's why to analyze the pattern, you don't require the positions of secondary maximus. Why? Because intensity of secondary maxima are negligible. We cannot observe these secondary maximas by our eyes. Intensity is so low. Okay? Only principal maximas you can observe. You can observe only principal maximas. So here this is the ratio. You can find out this is the intensity ratio of IS upon IP, and that is equal to 1 upon 1 plus n square minus 1 sine square beta. ठीक है, this is the ratio of principal max secondary maxima and principal maxima. So this is most of the aspects I have discussed. One or two aspects are left. So tomorrow I will complete this diffraction grating with numericals. I will discuss 7, 8 numericals, type of numericals they can ask, as well as one or two like dispersive power is there, resolving power, dispersive power is there that I have to calculate. Okay, and then I will discuss numericals of this. So tomorrow in the next class I will complete diffraction. Okay बेटा, thank you very much.
सर
सर हाँ जी बेटा, yes please.
डिफ्रैक्शन के बाद आप ऑप्टिक्स कंटिन्यू करेंगे क्या मतलब
Yes बेटा, इसके बाद after that I will discuss polarization.
ओके ओके अच्छा सर वेव्स में जो पार्ट है ना फोर्स्ड ऑसिलेशन वो पार्ट हो चुकी है क्या
हाँ वो बेटा पहले कराया था हमने.
ओके
After completing optics I will start discussing waves from simple harmonic motion, and then after that
फोर्स्ड वाइब्रेशन
superposition of superposition of waves and oscillation, then damped oscillation, forced oscillation, Doppler effect is there,
ओके
waves are there, ठीक है, different transverse waves, longitudinal waves. So all these aspects I'm going to discuss after polarization. First I will complete polarization, and after that, after polarization, first I will complete ray optics also, and then I will continue with this wave optics, this waves and oscillation. Sorry, okay.
ओके
So in this way, I will discuss each and every topic now in sequence. Okay, beta, please save all the slides. This is the first one. This is the first one. Second, third, fourth, fifth, sixth, seven, 8, 9, 10, 11,
थैंक यू सर।
वेलकम बेटा, गुड नाइट बेटा।